The resource packet that's in the note crate is stapled. So the first page here is the notes, and then this is the practice and the homework that goes with the notes. Right now for the video, we're only concerned with the notes portion, so we're going to cut this out. And we're going to cut out this box here, this larger box here. Okay. We're going to solve this equation using these steps. It's kind of a step-by-step process. We'll do these two together. You'll do this one on your own. So once you pause the video and cut those out, and I will do the same. So you'll see when I cut these out, these are actually kind of too big. They're going to take up the title of your entry, but fortunately, solving a system of equations by elimination, that can kind of be the title, and you can put the entry number here, and you can just kind of tape or glue this in. And then the problems that you'll do are going to be on here. Please do not glue these in yet. How they're actually going to go in is you're going to put a piece of glue on this gluing tab here, and you're going to cut just up to the gluing tab. So that we have a little extra space to work with, because we're actually going to be checking our answer at the back, solving it on the front, just so we don't waste a lot of paper. And let's start with this equation right here. We're going to solve this system of equations by elimination. So we have 5x minus 4y equals negative 48, and we have 3x plus 2y equals 2. So obviously we have a system here in two variables. We could graph these, and let's see what would happen if we tried to graph this one. Well, we'd end up dividing by negative 4, which would work out here. Our y-intercept wouldn't be a fraction, so we could do that. Might be a bit big. Here, divide by 2. So we could solve these both by graphing. We could solve them by substitution as well. But sometimes you'll notice as you start to do these problems, we have three methods to solve a system of equations, and each method is going to be best in certain situations. Like you wouldn't want to solve by graphing if your y-intercept is a fraction, because that would make it very difficult and very inaccurate. Substitution can be tricky if you have a lot of decimals or a lot of fractions in here, because there's a lot of steps to get rid of those fractions and those decimals, and in all those steps it's easy to make a mistake. As we go through these steps, you'll kind of see what makes solving by elimination so nice. And so let's kind of get started with that. Our first step is to arrange the equations so that like terms are in columns. So that means is make sure the x's are on top of the x's, the y's are on top of the y's, right? The constants are on top of the constants. The way you kind of want to think about that is if you're adding like 135 plus 62, when you learn to add these together, we write them this way because this is the ones, the tens, and the hundreds. And it wouldn't make sense, right, to add the ones and the tens together. Everything would shift over. It wouldn't make sense, right, because 135 plus 62 isn't going to be 1,412, right? It's going to be 197. So that's why it's really important to make sure that the variables are stacked up on top of each other so you don't make any mistakes. In this case they are. They're stacked very nicely, so we don't really have a step to take in this one. We're just going to rewrite them. And then 3x plus 2y equals positive 2. Okay. And even if you want to make this 2 line up in the ones digit, you can. Okay. But that's up to you. It's a personal preference. I usually don't, but it can make things easier. And certainly be careful of your signs here. Negative 4y, positive 2y. Once you start shifting things around, you have to make sure that if you want to move this, this negative 4y over, you have to bring it the negative over with it. So it would be negative 4y plus 5x if for some reason you wanted to do that. Okay. So we have our new system. We didn't have to change it much. We just kind of shifted things around so that we could work with it better. So my goal when solving by elimination is to eliminate one of the variables by adding down or subtracting down. So when I add these two equations together, I want to eliminate a variable. Okay. So if I were to right away add these two together, I would get 5x plus 3x. I would get 8x here, negative 4y, positive 2y. I get negative 2y, negative 48, positive 2. I get negative 46. That doesn't help me because I just have a new equation that still has an x and still has a y. So I've got to manipulate this equation somehow, or either one or both of these equations, so that when I add them together, I'll eliminate a variable. And that's what step 2 is about. It says multiply, if necessary, the equations to make it so that at least one of the variables has coefficients that are opposites. Because when I add opposites together, they cancel out. They make 0. So like negative 2y and positive 2y. If I add those together, I get 0y. Those cancel each other out, which is beautiful, and that's what we want. So 5x and 3x. So how can I either change this 3 to a negative 5 or this 5 to a negative 3? It's going to be difficult because I have to multiply by fraction, so x might not be the one that we want to work with. Let's work with this one. So I have negative 4y and I have positive 2y. I want to either make this a negative 2 or this a positive 4. And as you start to do more problems, you'll start to see which one is easiest to do. Hopefully you can see in this case that it's going to be easier to make this a positive 2y rather than reduce this one, because when I divide by 2, I'm going to get a fraction here that's going to make it kind of tricky to work with. And let's not overcomplicate things. So I'm going to take this second equation. If I were to number these 1, 2, I'm going to take the second one, which is 3x plus 2y equals 2. And I'm going to multiply that whole equation by positive 2. The whole thing. So every single term in there is going to be multiplied by positive 2. And that makes my new equation 6x plus 4y equals 4. And again, I didn't change the value because I multiplied everything by 2. I just changed the way it looks. And I changed the way things look so that I can make things cancel out or make things more easy to manipulate. And that's the whole process here. So now that I have my new equation 2, I'm going to use this equation now instead of this one. I'm going to add the equations together. So this is going to look like this right here. So I'm going to write my new system. I have 5x minus 4y equals negative 48. My new equation is 6x plus 4y equals 4. And when I add those together, 5x plus 6x is 11x. Negative 4y and positive 4y, those cancel. And this equals negative 48 plus 4 is negative 44. So now I've got this equation, 11x equals negative 44. And I'm going to solve for that remaining variable, that variable that didn't get canceled out. Divide by 11, divide by 11, x equals negative 4. So by eliminating the variable y, I've gotten x as a number. 11x equals negative 44, x equals negative 4. The last step is to substitute the value found in step 4, so you just figured out that x is negative 4, into either of the original equations and solve for the remaining variable. So I can make x equal negative 4 here or here and use the equation that I used to figure out the value for y. So let's do that to the second one. So I've got 3x plus 2y equals 2. But I know that x is now negative 4. 3 times negative 4 is negative 12. Add 12 to both sides. 2y equals 14. Divide by 2. Y equals 7. So my solution is negative 4, positive 7. And I, of course, want to check that at the end. There's not much space to do that on this paper, though. So we're going to glue this one in here, and we will end up checking those 3 other ones here. We're going to flip these up and do the checks. But now you've finished this kind of step by step with one example. You're going to either glue or tape that in. Right nice to the kind of top of your book so that you have enough space to put this one down underneath. So go ahead and pause the video and do that. Now we're going to use those steps to solve this equation here, this system. 18 equals 10x minus 3y, and x plus 3y equals 15. So in this case, unlike that first problem, we have to rearrange these equations so that the x's line up and the y's line up. I've got 18 equals 10x minus 3y, and x plus 3y equals 15. So I've got x and y on this side of the equal sign, x and y on the right side of this equal sign, so it's right over here, left over here. What I can do is I can just kind of rearrange this so that it's not 18 equals 10x minus 3y. It's 10x minus 3y equals 18. It's almost like reading it backwards, kind of. 10x plus 3y equals 15. And it's important to note here that I can move the equal sign over here. I wouldn't change this to a positive and this to a negative, or can rearrange things that way. All I'm doing is simply rewriting it. But instead of saying 18 equals this, it's this equals 18. And now everything's lined up. My second step would be, well, do I have opposites, or do I have to manipulate these equations so that when I start adding these equations together, they'll eliminate variables? And you can see right away I've got negative 3y, positive 3y. When I add down, those are going to cancel right away. 10x plus x is 11x. Negative 3y, positive 3y cancel. This is very nice. And 18 plus 15 is going to be positive 33. So I've got 11x equals 33. And I can divide by 11. And x equals positive 3. Now that I know x equals positive 3, I can put it back into this, either this one or this one. This one has smaller numbers, so I'm going to use this one. X plus 3y equals 15, but I know that x is actually 3. Subtract by 3 on both sides. Divide both sides by 3. Y equals 4. My solution is 3, 4. And I'm going to flip this up now. crease. Okay. And I'm going to check 3 and 4 for both of these original equations. So the first one is 18 equals 10x minus 3y. But I think x is 3 and y is 4. So does 18 equal 30 minus 12? It does. So that first equation checks out. My second equation was x plus 3y equals 15. I'm checking again for 3 and 4. Does 3 plus 3 times 4 equal 15? 3 plus 12 equals 15. Certainly 15 equals 15. So it checks out for both. So my solution is 3, 4. Okay. So this process is a lot faster than solving by substitution or solving by graphing, obviously. The concept's just a little bit confusing, and it can be easy to make mistakes. Certainly, once again, though, different systems are going to require different ways to solve. So, on a test, you might not be told to say solve by elimination or solve by substitution. Certainly, you should know how to do that, because more than likely you'll be given an equation where it's going to be required for you to use that. Even though I'm not going to tell you to use it, you need to know that that's going to be the easiest way to solve it. Next one, we're going to do this. Again, if you want to attempt this right now, you can just pause the video and give it a shot. But I'm going to go through the process of solving this one. This one you're going to do on your own and then show your teacher when you're finished. Similar to this system here, these variables are not lined up together. They are, however, both on the left side of the equal sign. So it's kind of a different situation than this one, where we do have to rearrange things, but it's not as simple as just putting the equal sign on the right side. We're going to have to move either this x over here or this y over here. The kind of general form is to have x before y, just like standard form of equations. It really doesn't make a difference which one you choose, but that's what I generally am going to do. That's probably what you'll see books do or professors in college do, but certainly it's not going to make a difference. So I'm going to move this negative 2y over. Now when I move it over, okay, I have to be sure to take this negative sign with it. If I move the x, okay, I'd have to make sure to move a positive 3 with it, and then, write negative 2y on the outside. You got to take the sign because this is technically a negative 2, right? Subtraction and negative are considered the same thing. So, again, just for conformity, I'm going to move the y to the right side here. So, my first system, or my first equation, doesn't change. I have 3x minus 2y equals 10. My second system, I'm going to write the 9x first, and then it's minus 2y equals negative 14. And now step 2, I've got to see, well, do one of my equations right away cancel a variable out, or am I going to have to manipulate it some more? 3x and 9x, that would be 12x. Negative 2y, negative 2y, negative 4y. I have to change something. This one's pretty nice. I'm only going to have to change this sign into a positive. So what I'm going to do is I'm going to multiply my second equation by negative 1. And that's just going to change the sign on everything. I'm just going to kind of make a squiggly line there to show that there's a step. So my first one doesn't change. I have 3x minus 2y equals 10. And now I have negative 9x positive 2y equals positive 14. And multiplied everything by negative 1. Now I could have multiplied the top by negative 1 as well. It wouldn't have made a difference. So now that I have these two, everything's lined up. I can add them together. 3x plus negative 9x is negative 6x. These two cancel. That's the point, right? Equals 24. Okay. And then my next step. Right here you see that I rewrote 11x equals 33. Some people I find don't like to kind of waste paper and rewrite this. If you can recognize that this is your equation, it's just got some space there. We can divide by negative 6. And x is going to equal negative 4. Now that you know x is negative 4, you're going to put that into either this equation or this equation and figure out the value for y. It might be a little tight space here, but we can kind of write down here if we need to. So I'll use the first one. It's 3x minus 2y equals 10. So that's 3 times negative 4 minus 2y equals 10. See if I can zoom in here. This is negative 12 minus 2y equals 10. Add 12 to both sides. Negative 2y equals 22. And then divide by negative 2 and y equals negative 11. And on the back you'll do your check. You can kind of box this in if you found that you needed that space. Okay, but my solution, I think that I want to check is negative 4, negative 11. Now that you've done your check, you know that the answer indeed is negative 4, negative 11. You're going to do this problem on your own. You're not going to do it on paper. Okay? So you're going to do the solution. You're going to make your check. You're going to show your teacher. And then you should have the notes portion for this entry. And you're ready to do that practice page solving by elimination. Probably not going to be able to do it on this worksheet here. You might need to use a separate piece of paper. It is two-sided. Okay. But you should have this all set in your book and you're ready to go.